All right, kiddo, let's see how this goes. So let's start back with the basics because I don't know how much you remember from chemistry. When you're looking at the periodic table like this, you can tell how many electrons an atom is going to have based on this number. So sodium has 11 electrons, okay? It also has 11 protons in the nucleus. So when you draw the atom, which I know we did a lot of this in class, you can fill up the atom's electron energy levels just in certain orders. The first level holds 2. The second level holds 8. And the third level will hold 8, but since this is sodium and we only need a total of 11 electrons, we've got 10 in there so far, so we'll only end up putting 1 in that energy level. Okay, so if you were trying to remember that, just to help you out a little bit, you start with the nucleus, and then the first electron energy level will hold 2, the second one holds 8, the next one holds 8, and then it goes up to 18, 18, and then after that it's 32 and 32, okay? Now here's the deal. Within these energy levels, you have some sublevels, or electron orbits is what they're usually called, or orbitals. Those orbitals can be s, p, d, or f orbitals. And s, p, d, and f orbitals all have different shapes. The s orbital will hold a total of 2 electrons. The p orbital can hold a total of 6. D orbitals can hold a total of 10. And f orbitals hold a total of 14. So it goes up by 4 each time, okay? Now, if you are looking at that orbital structure, you can kind of see where this ends up falling into these energy levels, okay? The first energy level just has an s orbital in it, and that's why it holds 2. The next energy level has an s and a p in it, and that's why it holds 8. The next energy level, level 3, has an S and a P. That's why it also holds 8. The fourth energy level has an S, and then don't worry about this number here, a D and a P. Now I know that it says 3D, but it sort of ends up in the fourth level. There are some complicated quantum mechanical reasons for why it's 3D and not 4D. Don't worry about those at this level, just kind of know that it's there. So again, that first energy level with just an S in it ends up holding 2. The second energy level with an S and a P ends up holding 8. The third energy level with an S and a P ends up holding 8. The fourth energy level with an S, a P, and sort of a D ends up holding 18. So we can see how that builds up this whole process here, okay? So that's kind of just your background information about where all this comes from. What you have to do for your class is to put the electrons into these orbitals, into these sublevels, so that you can see specifically what's going on with them. Okay, so here's how we do that. Let me erase some of this real quick. Hold on, bad video, just a second. Okay. So the order that these energy level follows, which you've probably been given by your teacher, is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, and then it gets even funkier from there because then it goes 6s, 4f, 5d, 6p. And again, this is the energy level that jumps up to 32 with the addition of that F in there. I know it's the 4F, but because of some energetics reasons, it fills later on, okay? 6p, 7s, 5f, 6d, 7p, and that covers every known element up to number 118, okay? So it never goes past that. If you need some help remembering what order those go in, because you have to do it for a test, then you can set up a couple of different things. There's this little arrow thing where you go 1s, 2s, 3s, 4s, 5s, 6s, 7s, and then you go to P, 3P, 4P, 5P, 6P, 7P. And so you just write them out like this: 3D, 4D, 5D, 6D, 7D, 4F, 5F, 6F, 7F, even though those don't exist. And you can just do an arrow like this that shows you what order things are going to fill in. So you go down through that. It's 1S, 2S, whoops, 2P, 3S, 3P, 4S, 3D, 4P, 5S, and so on. So you just kind of keep drawing diagonal arrows through here, and it tells you what order they fill up in. So you just write 1S all the way across the bottom, and then you write 2P, 3P, 4P, 5P, 6P, 7P, 3D, 4D, 4F, like that, and then you just go with these diagonal arrows down through there. It'll help you remember this order. So I don't know if your teacher is going to need you to memorize that order, or if that order will be given to you. It should be given to you because it's a stupid thing to make you memorize, but if you have to memorize it, that's how you do it, okay? Now, let's get down to the nitty-gritty of how to actually fill these things in once you've got it, okay? So you've got the order here. Let me just do an easy one. We'll do 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P, and we'll stop there, okay? Now let's say we were looking at the periodic table square for, let's say, let's do an easy one first. Let's say we're looking at carbon, and you just have to put 6 electrons in there, okay? So here's what you do. You remember that S's hold 2, P's hold 6, D's hold 10, F's hold 14. And then you just start filling them in here, okay? So we start at 1S. 1S holds 2. Now we needed a total of 6. So from that 6, we've entered 2, and we have 4 more left to go, okay? So now my next level, S, holds 2. So I put that 2 in, and now I've got 2 left. The next one is a 2P. P's will hold 6, but I've only got 2 left. So I put that 2 in right there, and that right there, my dear, that is the electron configuration for carbon. 1s2, 2s2, 2p2. And you put the electrons in these superscripts. That's really important. These numbers have to be big coefficients. And these numbers, the number of electrons, has to be small subscripts. Okay, so that was easy for carbon, 1s2, 2s2, 2p2. Now let's say we were going to be doing a bigger atom, okay? So let's erase some of this work here. Time out from the bad video while I get that erased. You're going to be fine. Okay, don't worry. Yeah, no, don't worry, you're fine. Sorry, my daughter is homesick from school today. Okay, so let's say that instead we were going to build iron, okay? Now iron has the atomic number of 26. So this time we're looking to put in a total of 26 electrons, which might take us a little bit longer, but it's exactly the same algorithm that you follow as you do it. So we start over here. I'm going to have 26 total electrons. I need to remember that. I'm putting in 2 to the first one because it's an S, so it holds 2. So I put that 2 in, and I've got 24 left to go. Next one's an S. It'll hold 2, so I put in another 2, and that gives me 22 left to go. So I take my P. It holds 6, so I put in 6, and I'm going to rewrite this up here because I'm running out of space. 22 minus 6 is, let's see, 16. Okay, so I have 16 left to go. The next one's an S. S's hold 2, so I put in those 2, and that gives me 14 left to go. So I'm going to keep on trucking. I come up to my P's. P's hold 6. Put my 6 right there. And I had 14 of these left. I put in 6. That gives me 8 left to go. Okay? And then I'm in an S again. S's hold 2. So I put in 2. That gives me 6 left to go. So 6 left to go. I go to a D next. D's will hold 10. I don't have 10 left. I only have 6 left, so I put the 6 right there. And there's my electron configuration for iron. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay? So it's just an algorithm that you follow every time. You take this same exact order that they always go in, 100% predictable. Find out how many electrons you need, and you start placing the electrons according to the capacity of each orbital. Okay, again, S's will always hold up to 2, P's hold 6, D's hold 10, F's hold 14. You cannot go on to the next orbital until the first orbital is filled. That's the only thing that you need to remember as you go, okay? Now there is going to be a trend that you'll notice on the periodic table once you have all of this done. And it can help you check to see if you are right. So the periodic table looks like this. You've got your first column here, your second column here, this whole mess of crap in the middle, and then a big set of things here, like that. Okay, terrible periodic table, terrible chemistry teacher there. But you can count out the electron configuration from left to right. Everything in the first column will end, sorry, not a 1s, everything in the first column will end with an S1. Everything in the second column will end with an S2. Everything through here is going to end with D1, D2, D3, D4 as you move along, okay, except maybe some F's when you get down here. Okay, so don't worry too much about those, but if you're in the top rows, they'll end with D's just like that. And then when the periodic table bumps up like this is called the P block. So the first row over here ends in P1, and then the next row, or the next column ends in P2, the next column ends in P3, up until you get to the very end, all of the noble gases should end in P6. Okay, so you can see the pattern that it goes through here, and then you can always check your work, like when you end up with your electron configuration, whatever the last thing in it is, you can look at where it is on the periodic table and make sure it's in the right spot based on that, so that you can check your work and make sure that you did it right. Okay, so I hope that was helpful. You can definitely still call me or send me pictures of your work so I can tell you if you've done it right or tell you where you did it wrong. Okay, bye.